Hello and welcome to this video tutorial for Creo Parametric version 3. This video tutorial will cover revolutions. Revolutions are similar to extrusions in that they're used to create features within a Creo part. However, revolutions are used for features with axial symmetry, where a cross-sectional area is revolved around an axis. We can demonstrate a revolve by creating a new part. We will call this example_2. OK. Now previously our extrudes required a datum plane for reference. When we go to revolve, we need a datum plane and an axis for reference. We will select revolve, placement, we will select the front datum plane, we will enter sketch view, and under this datum tab, select centerline. And this is what our sketch will rotate about in the revolution. So click once, twice, and middle click to complete. Now we can create sketches as per the extrusion video by selecting a rectangle, clicking the location of the vertices, and middle clicking to complete. Note that Creo has put in two weak dimensions that we can click and drag to make visible, and these are referenced as a diameter, which is a much easier way of working when we're doing revolutions. We can now create strong dimensions by double clicking this length, typing in 200 mm. Now we don't have a default dimension for the height. We can add one of these by going over to our dimension tab, clicking the normal dimension button, clicking this length, and then middle clicking to complete. Creo has now added a dimension that we can change. We can also fix the internal diameter of this revolution by clicking this weak dimension here, typing in our value of choice, and hitting enter. And we'll also make this rectangle flush with a dimension of 0. Our revolution is now fully defined, and we can press OK. Now if we rotate our model out of plane and refit the window, we can see that our rectangular cross section has been revolved into this ring section. If we look in the dialog box, we can see that by default this is revolved through 360 degrees, and there are some instances where we might not want a full revolution. So we can input a user specified degree, or we can also click and drag this white tab. Once this is complete, we can click OK, refit the window, and our revolution now appears in our work tree. So just to recap, revolutions are very similar to extrudes in that we need a datum plane for reference, and then as a user we specify the cross section that will either be extruded or revolved. The one key difference with revolutions is we also need to define an axis about which the revolution will take place. Now this shape on the screen is a very simple shape which could have also been achieved via an extrusion upwards. We will now look at a more complex example by editing our feature. So in the work tree, click revolve, right click, and we can edit that definition. We can change this back to a full 360 degrees, and under placement we can now edit our first section, and we will click sketch view. We can now delete this section by simply drag selecting and then deleting, and we can create a new section with the line tool. In this case, we'll just be drawing a series of freeform lines. And middle click to finish. Note that our section is shaded in yellow, which means it is ready to revolve. At this point, we are not concerned about any of these weak dimensions. We can just tick OK. And we can rotate that in space. We can adjust angles. And tick OK. And this is a much more complex shape that in this instance could only be completed by a revolution. At this point, it is now worth practicing some revolutions by yourself, remembering that to create one, you need to reference a datum plane and an axis of revolution. It also requires a slightly different thought process in that you can work in terms of diameters. As a final note, you can also remove material using revolutions, in a similar way in how the holes were created with our extrusion video.